of pixel perfect fidelity if you're careful doing certain limited things. So first I want to do a quick recap over the topics from last year with some updates. So I had my sort of top 3 or 4 things that I was pitching and working on last year, and I talked about a lot of them. Number 1 was Minecraft at the time, where that was our big triumph of we had the final meeting, and we had announcements just before Connect last year that Minecraft was a go. At that point, I had a version that was running, and I was like, okay, go, launch now, launch this, what we've got right now, it's great, it's good. But the Minecraft team coming onto it, they were like, okay, let's hold back, we need to get our footing here, figure out what's going on. And I was worried for a while whether they were even going to let me work on it, whether they were going to want to really take it in a different direction maybe than I thought that it should go. But it turned out, it all worked out great. I was able to go ahead and bring back my old, the stuff that I had done earlier, modernize it in their code base, and then kind of help and direct them through kind of all the updates that they wanted to do. There was a little bit of tension where I would have released what I had right there if it was up to me. And it's worth noting that, as I'm going to speak a lot about aliasing and pixel fidelity quality, Minecraft at that time would have been the most aliased thing on the store. It would have had aliasing between every little blocky pixel there, and I still would have said it was valuable to put it out. So everything that I'm saying about rules and kind of the way to do things and guidelines, they're all still guidelines, and it's certainly possible to have the value of something outweigh things that are negatives. But we got a lot of good things out of it from by the time it did ship, 6 months later. I was hoping for like a 2-month release time, but it took 6 months to get through it. But over that time, it was great to see the Microsoft team buy into Gear VR. At the beginning, I was talking about the virtues of having a swivel chair and being able to play the game like this and the value of the portability, but most of them were Windows developers. So of course, they're like, well, we're going to do the Rift first, and then we'll see maybe about this Android Gear VR thing. But over the course of the development, the kind of value of that swivel chair play and the portability and things like that, the team got it. And I'm really happy with our working relationship with the team since then. I was happy to do E3 promos and go to Minecon with them. And this is a relationship that should be going on great for a long time. Because it's integrated into their core code base rather than just being a VR version. Like they've done versions of Minecraft for some other things, and then the code bit rots and it's unsupported. But this is built into the very core of everything that they're doing. This is by far our biggest title, kind of the most important. I mean, Minecraft is arguably the most important game on the planet, and I'm really happy that we've got it on our VR platforms. I play with my family every week. Every Sunday we get in, it's our family tradition, and we get into our realm and we play Minecraft. I drag out my swivel chair and spin around in my VR headset. Other people on tablets and phones and everything. So the number 2 thing that I had last year was inside-out position tracking. And I got a bit of a lecture last year after one of my in-the-hall conversations got picked up and turned into a bit of a news story where I was essentially saying, complaining. I'm saying we've got a few dozen smart computer vision researchers, and they're working on all this esoteric stuff instead of solving the inside-out position tracking problem like I wish they did in spending the last year on. And maybe a little bit tact-free in that, but the basic, I stand by the basic position there, but it's a difference of perspective where if you come at this from saying that the future of VR is a PC-based system with static cameras, then the things that the vision team is focusing on, like eye tracking and face tracking and gesture recognition and room reconstruction, these are all great research topics, and they're going to be great features. But if you believe that the future is this portable mobile device that's going to require you to move around in the world, then doing any of those things first would be backwards, because you've got to have inside-out position tracking for your head before any of these other things really makes much sense. So I did have a little bit of a tirade about saying I think this is so important. This is the most important thing. It's got to happen, even if I have to do it myself. I worked hard on a bunch of stuff there. But the company did make the strategic decision that we did buy into standalone as an important direction for us. So now the experts are here, they're fully engaged, and they've got this. So I want to make crystal clear, because this gets picked up incorrectly in the press, that the standalone demos that we were showing over the course of the conference here, that is not my vision work. That's the work of the vision team there. Now, the demo got put together by a fairly epic crunch of people across the Dallas team doing all the Gear VR side of the works and the content side, and Menlo Park doing the new hardware bring up and all this. So it was a big team effort there, but I know that it does get picked up. Everybody knows I was working on inside-out tracking. You could follow it through the lens of Twitter as I would go through various things. But the productization work that's being done now is by the core vision team, and I'm super happy with with how it's going. There's maybe a little irresponsible part of me that would have been happy if it was lone wolf programmer goes and solves most important problem for all of that. But no, it worked out. And we are being told a little bit, don't speak specifically about much of the vision stuff going on. This is like way out in the future. Don't draw too many conclusions from it. But I'm suspecting the next thing that's going to play out similarly to this is about like hand and finger tracking, where we have a bunch of high-end research working on different ways with dedicated hardware and very specialized recognition algorithms. And we're in sort of this is not coming real soon. It's a little bit hard. We need to do different things. And maybe next year I'll be saying it's like, no, we'll do something simple with fingertip tracking and we can make a good user interface for this. And we have to go through a similar thing about waiting to get kind of company-wide buy-in. Because I do think that's the end goal for the billion users in VR is you have your simple thing and you do your basic touch interactions, and controllers are for the more dedicated experiences. And as all of our data is showing, at least half of the experiences that people are doing in VR are these more passive experiences. But definitely computer vision work. I had a ton of fun going through this, learning a lot. I'd love to sometimes give a really geeky lecture about all the details there, but it's a super important topic that's going to be shaping the world a lot in the coming years. So VR script was one of the other major things that I was talking about. We had identified this very real problem that's still with us today. Making VR apps is hard. We need to have some path to making it easier for people to do things where you don't need all of Unity or you don't want to fire up and become a native developer. So I had pushed this direction where I gave a live coding demo last year, and I was pretty happy with where we were going with this. I had this instant reload, very fast debugging, all sorts of interesting things there. But internally, we were going through some significant debates about what is the place of a scripting language in our ecosystem. As a company, what do we want to do with this? You're, of course, going to have some people that say, well, does this undercut our store? Are people going to be able to do scripted applications, and then there's no app revenue model? What does that mean as a company? And they're reasonable arguments to have. Obviously, I was saying that I thought this was really important, and eventually the company came around. We decided we do want to have some kind of easy-to-use scripting language. It's important. We'll be failing if we don't have this. So the next thing that was, or an action of that was, what the hell, John? Lisp? Are you serious? And I kind of knew that was coming. That the work that I was doing with Racket, which is a scheme or a Lisp dialect there, was not the broad. Not likely to have broad acceptance. And the conventional wisdom, of course, is it's got to be JavaScript today, that if you're going to be doing something, it's got to be JavaScript. And I'm still not completely sure how I feel about that as received wisdom, but so Michael Antonov had done a version of VR script where it was set up in a nice way where we could plug in the language. It just communicated over pipes. So we had my Racket version, and he did a node-based version that let us use JavaScript for that. And we were making some progress with that, but it was at kind of a weird position where I wish I could have just dumped out what I had, even if only a fraction of the people were willing to use or maybe even learn a new language. I think it still would have had some value, but as we were meandering around on this, making some progress, there got to be a few important points about WebVR came out. Samsung announced that WebVR was working in their Samsung Internet browser. And that started a flurry of conversations internally where there's a huge draw to the power of being a standard. You want to say, well, WebVR is a blessed standard. Should we be using this so that people can work across multiple different platforms? There's got to be goodness in a standard. Now, to some people, that's almost a talisman. It's a standard. It's got to be good. And I try to evaluate things more objectively on the actual merits of it, saying that WebVR is a very, very, very tiny thing. It's just basically a way to direct WebGL rendering to head-mounted displays and then read some input tracking from it. And I always thought we should, of course, support this to the best of our ability. But the best of our ability on this is still going to be fairly limited. You're going to be limited to what you could do in a WebGL sort of framework. We can go ahead and ATW it, and we can get as low latency as possible, but you're still going to be limited to basically working inside this web stack. Now, some people can make a pretty impassioned argument that the web stack practically runs the world, that so many important things are built on the web stack, and it's not just like WebVR as one small tiny piece, and then WebGL, and then whatever things that you layer on top of that, 3JS or A-Frame or whatever, but it's the whole way that browsers work and the things that go on in browsers. And it's a powerful argument, and I am hesitant to do battle too fiercely with that argument. I do think that there is a lot of value there, but I'm still not bought in that should be the foundation for virtual reality. I mean, I think that it's important that we've got to have that, and we are getting some surprising lessons from the Samsung Internet browser is always right at the top of our apps list in terms of the time people spend in it. Now, obviously, it's largely used as a video playing app, but there are people doing actual web things in VR, even though it's not a great experience for it. Especially at the beginning, it was not very good for text rendering, and it's not optimized for any of these things. But there is this clear pull for people to want to experience the web in different ways. So I think that we do need to do something with that. And for me, the killer argument for WebVR is that I don't care about portability across different devices. I think that it's fairly limited to say against different VR devices to say, well, you can run this on Gear and Rift and Vive. I think that's far, far less important than the idea that you can run this on a mobile phone or your PC browser. So an experience where you could be scrolling through your Facebook feed and you see an interactive WebGL system running right there that goes out to billions of people, that's a reason to construct some of that content that the fact that it can play in VR then becomes almost a bonus. I think that people are radically underestimating the difficulty of being cross-platform across like Gear to Rift. It's a 50x or so difference in absolute raw throughput, and if you're not taking advantage of any of the platform tricks, it really is just that big of a difference about how many pixels and vertexes you can draw. I've always said that there's not a Rift game or experience that I've seen that I don't think I could capture the essence of on a Gear VR class of hardware, but that's not easy, and that's coming from someone with a lot of domain-specific experience there. So I'm not super bullish on this grand world of we're going to have a ton of WebVR content running on a bunch of different things, but it's definitely going to be running. It's definitely going to be a platform that makes sense for a lot of companies to distribute content on, because they will be able to author things in a way that they can reach conventional viewers, and then VR is the bonus. Whether it's high-end VR for location-based entertainment type things for showing things off, or hopefully people getting limited enough content that runs on Gear VR. But it won't be taking advantage of all the kind of some of the neat things that were happening in VR script was like automatic use of layers, automatic use of background speculative panel loading, and some of these things, all the things that we were doing in our first-party applications. That's really not there in WebVR. Maybe we wind up extending it in various ways to that, but then you're not a standard, and then you have little if-def regions sort of written to the different things. That may be the world that we wind up in. But I worry that it is just this massive thing that we can't drive very nimbly, because it was interesting listening to the people working on it, where they would say, like, I thought UE4 was a large code base, but the Chromium code base is just a whole nother, probably literally order of magnitude about all of that, and just figuring out how to get the thing to build, let alone plumbing all of our special features into there, is a really big deal. But there's so much force behind the web ecosystem, and there's a saying in rocketry that given sufficient thrust, pigs fly just fine. And I'm very hesitant to bet strongly against JavaScript or a JavaScript ecosystem there. One of the other things that was a big deal last year was the first social applications that we had, where we had our social, Twitch and Vimeo streaming that had one-cut-it avatars and the first social interaction. And I was super excited, where we had a poll afterwards about like what people thought of the different things that they saw at Oculus Connect. And the social experience was right at the top. This was the thing that people thought was the most exciting thing that they were seeing there. So internally, we have one of the things, it's been a travesty at Oculus, where I think we have had 5 different avatar scene, development plans and strategies from the beginning of the company. We've got the Rift one out here today. We have gear analogs of that being developed. We have the things you saw in the keynote that Zuck did. We have another team working on something like that. We had 2 earlier ones done by other people. So we have not had internal alignment about that. So the social stuff that got pushed out was unfortunately left to pretty much wither, where we put it out there were some people in it, but we watched the users, and it fell down very quickly. So you got to the point where, well, if there's 20 people in our social stuff, this is not exciting, or it looks like a direction that we want to work on. But of course, I'm like, well, we need to be doing things. We need to be out there finding what people are doing. This, watch movies with strangers is always a weird thing. It's not this basic thing that you want, but it's the first step where we need to get out there and kind of figure out where we need to go. I mean, I'm frankly jealous of companies like AltSpace and VTime that are out there, in the mix, building communities, learning what the users want to do. So, of course, in the end, we have the power of Facebook, and I think we're going to be just fine in social eventually. But I don't like eventually. I want us to not lose a tempo. Let's get things done sooner rather than later. So we have a number of different social things that are in play right now, where our platform team mostly focused on friends and like groups and matchmaking and things, sort of a conventional Steamworks game-based sort of approach to social. And I have been pushing more for a Facebook-oriented sort of social, and there's several efforts that we're doing. Like, one of the directions that's still going on as a kind of an outgrowth of the social stuff from last year is this notion of arena-based social, where we want to be able to have not 8 users or something, but have it set up scalably so that we can have hundreds or thousands of users. And I think the idea for the first pitch talk on that is that we'll probably try to do a John Carmack lecture or something, and just see how many people we can pile in to see what we wind up hitting as the limits. But this is doing things like server-side mixing of the positional audio. The current social stuff does positional audio based on just the locations of the different people. Each stream's a separate one, and they're mixed with the very high-quality HRTF. The mass social stuff mixes everything on the server into an ambisonic mix, which is then presented to the client, so you can move around in that, so doesn't wind up having a scalability limit based on the number of users on the client, and it can go up to several thousand on the server. So that should be fairly interesting. Kind of the last hurrah of the old social stuff is Otoy is just launching an update of their Orbex media player that has a lot of really interesting things with shared user content, where we've been pushing for something like this for a long time. I've been saying that if you could just have a web browser that multiple people could interact and poke on, that's potentially a killer app all by itself. I keep saying that my example for social is watching my kids and their friends just huddled over a tablet, poking at it, watching YouTube videos or whatever. And I think making that really, really easy to do and work well is an exciting thing. So Otoy's got some things with some great content sponsors and people. There's interesting content that you can go in and poke at with the existing social structure, but that's also being set up for a coordinated launch and the way the platform is migrating. So every year I talk a lot about the different immersive medias and the different things that we can do as with photos, videos, and whatever. And I always have to push a little bit about back against this notion of sort of the VR snob, the people that are, that's not real VR, looking down their noses at the media playback. I mean, of course, we can take the pragmatic ground of saying, well, our not real VR has 10 times the users of your, quote, real VR, and just go with where users are actually demonstrating what they want to do. But I do want to make an old-timer analogy with some of that, where when Michael Abrash and I were doing some of the really early stuff with Quake, or even before that at Doom, there were people that had worked with real graphics, people that had Evans and Sutherland image generators or silicon graphics systems, and there was a very similar feel to this. People looking down, it's like, well, you can't call that 3D. It's not even really 3D. It's like 2.5D, and look at the aliasing, some things that I'll even say here. And And I feel the same sense of that, where it's not a question of whether it's real or not real, it's whether it delivers value for people. And clearly what we were doing back then, in the Doom and Quake days, it was terrible graphics by a standard of people that had these high-end, fully filtered image synthesizers, but it did deliver real value. And I think that's where we are with VR today, especially on Gear VR, where you look at it and there's a ton of things missing, but the real question is, can you deliver value with it? And I think we already are, but there's still a whole lot more that we can do, even on this exact same platform. So video's gotten one big bump where the domestic S7 and Note 7s can now do 4K 60 frames per second decode. And that's, that's great. It's twice what it was before. It was 4K 30 frames per second. And this means that where we need the pixels stretched around for 360 panoramas, you can get twice the resolution. But the problem is, it's like it takes at least half again as much bit rate. Not quite twice as much bit rate to double it, but it costs a lot more bits. And we're already skimping on bit rate quite a bit when you look at the bit rate that you get from a Blu-ray. And that's for projection onto a 1080p screen sitting in front of you. And we're decoding 4K videos at lower bit rates, stretching it all the way around you with giant pixels out. So I'm not sure where that's going to end up. Are people going to be willing to download gigs of content to get a long form or even medium form 360 entertainment at 4K 60 frames per second encoding? Now, we've been doing the viewport dependent streaming with Facebook. And this is one of those things that for a lot of people, it works out just great. You look at that and it's up to a 4x quality improvement. Some people really notice that when you turn quickly, depending on your connection and the phase of the moon and whatever, you may have a fairly stale, blurry blue view that comes in that snaps back to a better one. I still think we've got a lot of room to improve that. We spent a lot of time on a custom protocol driving that and didn't get the success that I had hoped for with it. But I still think I'm not yet convinced that we're anywhere near kind of maxing out what we can do with that. For streaming, that seems to be the only hope. It has to be this very focused direction. And we've gone through a lot of changes from pyramids to offset cube maps. And there may still be different projections that wind up working out better. So I think I still have high hopes that we're going to get a doubling or tripling of quality or total appreciated quality, counting turning around on that. And that ties into the video streaming as a service SDK stuff that's going to be coming up to allow people to push 6K by 3K equarex to the Facebook infrastructure, have them all transcoded to this, and use that inside your own native applications. But there's some other interesting directions, like the March Madness basketball application. Instead of going with full 360 degrees, it went with a 180 degree by 60 degree cylinder. And that allowed them to take the same 4K video and draw it onto this much reduced pixel area, so it got many times higher pixel fidelity for the same kind of 60 frames per second high quality motion. And I saw, like, one of the apps that I reviewed on Wednesday was taking good quality 180 degree hemispheres and similarly getting a factor of 2 pixel quality over doing a full 360. I think there's still very good opportunities for doing things like this. Someone made the, I thought, kind of insightful comment about the different ways that you use 3D media, where there's some things, like if you want to be in the Taj Mahal or the pyramids or something, everything's equally valuable. You look around, you appreciate all the different directions. But probably the majority of content that people would like to create does have some degree of focusing. And there's a lot of options that you've got here. It could be just a 180 degree camera, which then avoids the whole camera mess of how many cameras and what your stitching is and all of that. Or you could capture a full 360 and have lovely stuff sitting in your master file so you can re-render it out at different future platforms. But you might wind up using an offset cube map projection or something to give great quality for the people right in front of you, or the people today. So one thing that's a big negative that came up this year is the first year of, with the Innovator Edition, I remember having a conversation with the Felix and Paul guys, and they were complaining about you would see a tiny little tick, like a dropped frame, about once a second. And I was impressed that they even noticed that. But the difference is that they master everything at 60 frames per second, but the phones are playing out at like 59.2 or 3. It's not even the 59.99 NTSC sort of thing. It's just phones are not exactly 60 frames per second. So what happens is play the frames, and then it would drop a frame there. I had always been saying that we should really fix this because 60 frames per second content is what makes things feel really fluid and you're there, and especially for sports content, it's important. It's one of the things that makes it look better than a traditional video. So I finally sat down to at least go gather some real data recently, and I noticed some other things about some apps, just video having a lot of stutters. I wasn't sure whether it was our streaming stuff or, or something more fundamental. But when I finally sat down and captured data logs really precisely about when the frame is on the screen, when it's being decoded, I expected to see a nice linear graph of it going up and having a little tick and then going up. But instead what I saw was for half a second, nice and smooth expected, and then a huge mess for the other half of a second. And this was completely repeatable. It's most obvious in 60 frames per second video, but it's affecting everything, 30 and 24 frames per second as well. Like a really obvious place that you can see this in the recent Yellowstone video from Felix and Paul. There's a time-lapse shot of like clouds rushing by overhead. And you can watch anything in a 60 frames per second video it's going nice and smooth for half a second, then kind of juddery, and then smooth, and then juddery. Now this is all a result of something that changed in the way the video decode frames were released. And Android actually made a lot of improvements for traditional video display, where in the old days, you would decode videos and just whatever frame is last decoded, it gets pitched to the compositor. And nowadays, you can have a specific release time assigned with each frame. So ideally, you get several frames ahead, you're decoding a lot of them, and you say this frame is going to be released at this nanosecond time, this one at this nanosecond. So even if your app falls behind, something else happens, you may have many frames pushed ahead, the compositor will pick up the right one. We don't have the ability to do that right now in VR for a few reasons. One, Android doesn't let you get at different elements of the external image stack. I mentioned this to some people at Google, and it sounds like they might be adding this, and it seemed like a reasonable request to let GPU clients get at some of the same information that their privileged surface flinger does. But right now, you don't have that ability. But we can fake that by building a chain ourselves, basically copying it over and duplicating the work in our own queue. And I essentially had to do that same thing for Netflix last year because they had to, they were relying on it being queued well ahead and the audio would get out of sync. But we need to push this for essentially all of our videos. So we build a bunch of frames ahead, and we will let them be released when they need to be. We can get halfway there with the existing frameworks, but this is one of the things that we're going to be revving our low-level VR API for, to allow this notion of lots of layers that have different time releases, so that if you want to, you could push 2 or 3 frames ahead. And this is where, with asynchronous time warp, if you're looking around on a static scene, it can make up for it largely as you move your head around. But if you have a video playing, the video will still skip its frame because it can't just figure out what it needs to change there. But if we have multiple frames queued ahead, it can pick the right one. So this turns out not to be trivial for a bunch of reasons, some of which, like, we have ways you can play back video. If it's side-loaded, it may be playing back directly. If it's a cube map, it always has to be copied over to another texture. If it's streamed, it goes through a different path. There's a bunch of stuff to work out. But I do expect in the coming months to have some significant improvements, most noticeable in 60 frames per second video, but it will help everything. With 360 photos, getting Facebook supporting them is, again, a huge, huge thing. I mean, there are probably more 360 photos generated, since Facebook started accepting them than there were in 2 years prior, because now people have a real mainstream place to put the photos out. So Facebook embracing first 360 videos and then 360 photos is a really good deal. When I first looked at the ones coming in from the Facebook, like from Zuck's lead-in post for this, I looked at it and I thought there's something wrong with the quality of this. It was a city skyscape, so you have lots of the buildings with the windows, repeating patterns across all of it. And I could pretty clearly see that this was an aliased view of it was a nicely filtered view, but from aliased source, where I could tell from the windows and things that it was skipping along some of these pixels and rebuilding a new image that was then filtered nicely, but it was not right. Digging into that a little bit, it turns out that the Facebook ingestion is limited to 6K by 3K equirects. And the problem with that is that if you start with a bigger one, like this was probably a professional image that might have been at 20K by 10K or some very large value, it's completely up to the client that's uploading it, whether it's Facebook for Android, Facebook for iOS, or for the web. The client, each one can do a different thing on how it decimates down to 6K by 3K before pushing it up to the server for conversion to cube maps and all the different things there. So that's an important lesson. Anybody authoring images for Facebook right now, you should pre-filter all of your stuff down to 6K by 3K with a high-quality offline tool, and then send it to Facebook. And then beyond that, we were always converting them, I think we still are, always converting them to cube maps, which is this additional resampling step. But if you've got a 6K by 3K equirect and then you convert it to a 1536 by 1536 cube map, there's always a loss in quality when you're resampling. So what I'm hoping that we wind up doing, we have the ability to do this. I don't know if it's made it into the code base yet, but we should be able to directly render the equirects. If we know that we would be taking the highest res version and it's limited at 6K by 3K, we should just take that directly. One of the things that makes that possible now is we didn't have this a year ago, but we have direct time warp layer support for equirect images. There's trade-offs with that relative to the cube maps, but if you know that you've set everything up correctly, it can be a good argument for it. One slightly new thing that's at the fringes of improved quality is that the best way, like all of our 360 photos, again, all the great stuff that you see in 360 photos, kind of the best quality stuff that we have on our platform right now, they're all 1536 square cube maps with MIP maps. And if you look really, like if you do map visualization, the interesting thing about being in a cube is we pick the resolution so that the area that's pretty much right in front of you on a face is at natural resolution or slightly stretched up. But because of the way the lenses work, you lose resolution as you're going over to the edges. So unlike a normal 2D view, you draw something on the screen, it's the same resolution across the entire thing. Presenting a flat image in VR, you get less resolution at the edges, so it filters down into MIP maps. Basically, it goes down to the first MIP map around the edges, and if you look straight down the corner of a cube map, then you are touching parts of the second MIP map below that. Now, trilinear filtering does a pretty good job. I recommend everyone enable that. That's one of the first things I say in my app critiques is if I see something first that has no MIP maps at all, that should basically be an app rejection at this point. But I still do see things where it's a more subtle thing where if you've got it on linear MIP map nearest rather than linear MIP map linear, you can see kind of a line crawling as it changes between the levels. But trilinear smooths all that out. But it's still not perfect. I mean, I do kind of keep elbowing some of the GPU vendors about it. It would be nice to have a better filter that doesn't wind up blending between a blurred image, a too blurred image, and a too aliased image. Blending between them gets you close, but there's still hints of aliasing, and it's not quite as sharp as it could be. Something that I tried recently that turns out to be of general applicability is not using MIP maps, but pre-filtering the images. So if you know that a given part, say right in front of you on the cube map, that's going to be fine. That's always going to be fine, wherever you need to look at it. But the edges there needs to have a broader filter kernel across it. So you can take an image, if you display it without any MIP maps at all, when you look at the corners or the edges in different places, they'll alias, and you'll wind up getting some of the sparkles there. But you can go ahead and pre-filter the single image and then have no MIP maps and get a higher quality. So you can be a little bit better than the bilinear quality. You can do things like make a 2K by 2K cube map, which will be slower, but because you don't need MIP maps, it wins some of it back. Pre-filter all of this properly, and that's a small step up over our previous best. So that's our current gold standard for the best that you can do in sort of static imagery. And you can apply that also to equirects, where equirects have if you've ever looked at one of them, they've got the problem of at the poles, they've got what should be 1 pixel stretched across 4,000 pixels. And depending on how that was generated, if it all came from stitching low-res cameras, it's all frequency bounded anyways, and it doesn't really matter. But if it came from a very high-quality, high-res equirect, or if it came from ray tracing something, then you have high-frequency data up there that you can't represent. And you could have something that looks great at the equator, but look at the poles, and you've got kind of a fizzling aliased mess. But you can pre-filter all of that out. So that's kind of masterclass level quality stuff where it's not that important relative to the other things, but it is a tiny step up in quality over what we've demonstrated so far. With 360 photos, we did a lot of work on doing progressive JPEG loading that In hindsight, I think probably wasn't worth all of the effort. It's surprising that it turns out to be in progressive mode. You spend a surprisingly large fraction of the total image just loading the basic components to be able to present the image up. And it's probably a better idea for anybody doing large-scale 360 image viewing, just having explicit thumbnails. And I know many other companies already do that, and that's probably the right thing to do now. Progressive JPEG, not really worth it. And I would go, when I take a low-res image, to do the nice thing that everybody's expecting now about not just the tinted bilinear stretch up, but do a nice Gaussian blur, so you've got a blurred image before the next one comes in. I'd still like to use H.265 for still images, get better quality for a given bit rate, but there's still licensing questions about that. Audio, it's great to see the ambisonic stuff going into our SDK. I think that this is something that we should have just like the equivalent of clip art, but clip audio for the different scenes, and every VR thing should be having something going in there, at least if you've detected people have headphones on. It's perhaps arguable that if people don't have headphones on, you don't want to add just extra noise there, but if you do have headphones, it's a good thing to add there. Voice is still underutilized in VR apps. It's one of the best things in terms of adding quality. Voice, in terms of media, is relatively cheap. You can get professional voice actors for not all that terribly much money. The question that comes up with that, though, is localization, where you probably can't get 17 professional voice actors appropriately for your title. And that's the question of, is it better to have voice in one language or maybe a couple languages and letting the others have subtitles? I would argue that it is, because especially for gaming entertainment, the shape of the successes in gaming it's a sad thing in some ways, where it's like this across all gaming industries. But like, I look at our sales charts and things for Gear VR, and we have the top 10's doing great, the top 20 or 30 are doing pretty well, but it falls off for the bottom 200 are not doing very well, and this is the nature of gaming across all platforms. It is a hit-driven business. So sometimes modest improvements in quality relative to other applications can be significant. It's kind of like the dogfighting analysis, where you don't have to be a lot better, you just have to be a little bit better. And I would argue in many cases that you never want to not do something that makes it better because it's not available everywhere. So I would suggest use voice as much as possible, even if it does mean that maybe it's not as good for the rest of your markets, but pick the ones that you care about, and that's still a relatively cheap way to add useful things. The big announcement for this show, of course, was working on standalone. We got to give some demos for a bunch of people, but we really can't say too much about it. It's exciting in a lot of ways. On the technology side of things, one of the most exciting things is being able to have total control, not having to be sharing it with a phone, where we have a good, our working relationship with Samsung has allowed us to do, I think, a really magical thing with Gear VR. But there's no question about Samsung is worried about selling all of these phones, and VR is important and useful here, but in terms of what happens in the software stack and what's running, as it should be, it's totally dominated and driven by the phone use case. And that does mean that even once it gets past Samsung, then there's whatever stuff the carriers throw on it that even Samsung can't control what they do. And I've had many sad times when I'm looking at performance optimizing something, I get a systrace and I see this wall of activity going on, and I'm hunting down going, where is the actual app that I'm tracing? Because there's all this other stuff going on in the background. And this is causing us thermal problems. This is some of the stuff that drives us crazy, where we can have a developer that says, I can play my game for an hour and a half. Why are people getting these thermal overheats? And some of it's climate, people in just warmer places, but some of it's also the other things that they've got running on their phone. So it is super exciting to have the idea of having total control over it. And if we can make mobile-based hardware much closer to the way you can develop for a console, there is a large factor of quality improvement that we can get from that. I've always said that consoles can deliver twice the performance for the same amount of raw processing power, just because people know what they're aiming for. And when you know what you're aiming for and you can use all the facilities there and you can tune it specifically for that, that's a big win. Right now, rightly so. Many developers just say, this is a mess, it's different on the different platforms, I don't know what to do, it doesn't make that much difference as I'm tuning it because different things are running. But if we are able to get to this where there's nothing running on it that doesn't directly impact your VR experience, that's going to be great. To be able to look at a log and not see crazy things going by that you have no idea what they even are, but to see the log just talking about things that actually matter to VR. The thing I've been kind of nudging Samsung about for a long time, my sneaky plan to try to do that on the phone is if we could just push everything that's not VR related, not kill it, but push it onto one little core and run it at 300 megahertz and let it just kind of sit there and fight over the crumbs and leave the main cores for us. That would be a good thing. I still think that's feasible if that requires kind of fighting at the larger scheduling levels of things, but I have some hope that we could get to that point eventually. And the big thing, the engineering side of things with standalone is this possibility of really being able to throw more, literally, power through it, more electricity through the core to be able to get more power out of it. Because as developers on Gear VR, we can't even use 1/3 of the actual power that's there. We have our GPUs maybe at half the peak clock rate, but the CPUs are often at half, but we can't do like all the different video encoding things and Wi-Fi and GPS all at the same time. I heard an interesting statistic recently where the hardware vendors have something they call a power test virus, which is something that tries to blow all of the power possible into one of these just to make sure nothing shorts out or that the thermal management actually takes care of it. And I had always been thinking, because I've done similar things like when we were trying to do asynchronous time warp on CPU cores, and it was easy to get like 60 seconds, have the phone overheat. But I was hardly trying. That was just run the CPUs there. What if you run all the CPUs, all the GPU, max Wi-Fi, max max static memory read, all this stuff, throw everything at it, and apparently it can get up to like 25 watts draw instead of the normal maybe 3 watts or something. So this has to be a case where the hardware has to very quickly trip that or stuff will just fry. But with good thermal management, you should be able to, like if you've got all of that power available, if we can pull all of it out with thermal management, then we should be able to make things that are a couple times better than what you wind up getting on similar mobile hardware. So that's pretty exciting, but there's unexpected challenges for that, where PC builders are used to slap a big heat sink on it, put a fan on it, liquid cooling, whatever, and you can draw hundreds of watts out of high-end PC hardware. The CPU core the surface can get really hot, you can pull lots of power out of it. But in mobile, you've got the problems that a lot of these are stacked dies where you have, you've got your CPU cooking away there, but then you've got memory literally stacked on top of it, and then it's in a plastic case. So these are all terrible for thermal dissipation. So there's interesting questions about nobody's trying right now to run those chips as hot as we would like to run them. So there's going to be exciting things as we kind of figure out the engineering there. There's other things that we can choose to take advantage of, like the Qualcomm chips they've got DSPs as well as CPUs and GPUs, and Qualcomm talks about kind of their three-pronged strategy of, you don't want to think about just CPU, GPU split, but also DSPs. So some things can go there, and that's a reasonable way to do things. Other vendors are starting to add similar DSPs. You can hijack if you're not on a cellular network, you can hijack resources that are normally used for your baseband processing and also use those efficiently for some other things. And maybe if we've got our own system, we can get in some of my pet ideas like the demand page GPU memory, being able to just memory map a bunch of flash and have it come in as necessary. That I'm unlikely to get that into Android directly, but maybe I can get somebody to try that out on our own hardware, which would be really exciting. So the core issue here, though, is that we need to build better apps. I mean, there's no kind of better way of saying that, is that our applications, we're not held to a very high standard right now because VR is brand new. People aren't putting in that much effort to it. Everybody knows what a AAA game looks like with hundreds and hundreds of man years of effort put into it. And we know that the small teams that are building small VR apps, you don't expect it to kind of have that level of professionalism. And the same thing with apps. A lot of people think that, apps are easy. There's all these, like how to make an application in a weekend or something. But making a good application is still a very hard thing. There's so much work that goes into UI and user testing and all the things that really make the difference between an also-ran and the thing that leads the category. So stepping up, really bringing us to the next level on our applications is the key to getting VR to really take off, where we are coasting on novelty and the kind of initial wonder of something that people have never seen before. But we need to start judging ourselves not on a curve, but on an absolute sense. When you look at an application here, yeah, there's no way you're going to have the same effort put into it, but can you do something with VR that makes it have the same value or more value than what these other things have done? So we need to be harder on ourselves. We need to judge ourselves harder, make sure that the things that we're doing really do stand up and deliver value. There's the joy and wonder is important, even in applications. Like games are a lot about just the sense of wonder. You might have a disposable experience that you go in and you say, that was a great half hour or an hour of time I played. I'm happy with that. It was worth my money. But we need applications that are going to keep people coming back week after week. We want our weekly active users where people come back in every week. So Minecraft is my weekly active VR application. We need many, many more applications that cover other people's wants and needs that make them come back every week and use it. So I did 6 hours of formal app reviews on Wednesday, and many more impromptu ones in the halls afterwards. And there's a kernel of value and goodness in almost everything that I'd see, but I had comments, specific comments about almost everything there. By the way, the format was obviously not spectator friendly. We weren't thinking this too much through, where I thought this was just going to be my normal hallway conversations just in a room, just so that we're a little bit insulated from the noise and whatever. But it turned into a thing with a queue of applications coming in to do this, and it was horribly boring for people seeing me with a headset, turning around, talking about something nobody else can see. That's an excellent goad to make us get a easy to use overhead-free streaming system going for next year. And for those of you that have fought through that, you've got things like there's a version of Chromecast that would work that gets it to a separate TV, but then it winds up glitching up the view inside there. And in hindsight, I could have gutted through that. I'm not that sensitive to some of the disturbances, and mostly I wasn't talking about exactly the performance frameworks, the performance metrics that I was looking at. It was more other things, so I probably should have done that. But we do have work going on right now for setting up live streaming, doing our video encoding, like pushing it to Facebook. So productizing that in a way that it's so easy to let anybody do that. And this is where an important part about features is it's easy to imagine this being some fairly painful thing where you go into universal menu and you gaze type something in to get it up there. And we want this is going to be an excellent use for it, where I'm going to say next year I'm going to do the same thing, and it needs to be so easy for this to happen that everybody that's walking up with their phone can say, okay, I've got it live streaming and it's going to be showing up on that monitor there that everyone can see. That's actually a fairly big challenge to make things that simple. The technology of just making it work. We've got the video encoding, we can pipe it to different things, but this is the difference between that first glance of a feature existing and making the feature a killer feature. And that's not going to be easy, and it would be easy to punt quickly and say, I've demonstrated proof of concept, now we need to kind of take it to this productizable level. And honestly, I often get to do exactly that because of my position. I feel guilty about it sometimes. That's how our video recording went. It's like, okay, I made a proof of concept. I've got a video out here. Now, someone else, James Dole in this case, went and actually turned it into a feature that handled permissions and doing all the other things there. But that's a theme across all of this, where that initial bit of magic, to be responsible, we have to take it past that. We need to go ahead and turn it into an actual really good feature. So I am unabashedly advocating for Gear VR. I feel that I need to because the alternatives are everybody loves working on Touch and Rift, and it's magical and easier. It's still not easy to make a Gear VR app, but when you can throw 300 watts of TDP at it, it's sure a lot easier. But I come up here and I say, the future is mobile. I think that as we look towards 1 billion people, that it's not going to be on PCs for this. There are maybe 100 million PCs that can do VR in various ways. But I believe in the mission and how Facebook bought into Oculus about there will be a time with 1 billion people using VR. And as it approaches that, it's not going to be this higher and higher bar of power that you're getting to. It's going to be a lower and lower bar of adoption, where we started saying that a Note 4 defined the minimum bar for what I thought reasonable VR would be. There was broad debate about that. Many people thought, no, Rift defines the bar, the minimum bar for what acceptable, useful VR is. I think that we're going to find that that sort of Note 4 level of power really does define the minimum bar, and we go down to cheaper and cheaper headsets, cheaper standalone solutions. Instead of having $50 phones, you have $50 phones that can eventually become VR devices. So this level of performance I don't think is going away. Things get a little bit easier, but it's going to stay hard. And I think that that's where the real value, where you can impact the most people are. And it is like a puzzle, and I know different people have different views on this. I love the challenge of kind of working in the smaller box, finding the value, making the hard decisions, because it focuses you. It makes you really decide if you can only do a subset of these things, you'd better pick the right subset, the one that's the most value to your users. I love this micro-optimizing approach, but lots of people don't. Lots of people just want to be, it's like, I have my vision, and I want my vision made real in the easiest possible way, with kind of the least effort so that I can do more things. On the PC, I think that the PC is going to be like the creative class. It's the laboratory for things where it is amazing what we can see and all the different things people are trying out, but we mine all of that and figure out what do we want to try then pushing out to the millions of people that are on the lower end systems. And it is a matter of, you can approach all of these things. Again, I think anything people have done on the Rift in terms of a presentation, the essence could still come through on a lower end system. We are used to, especially as game developers in the modern age, doing all of these incredibly sophisticated things that honestly have fairly limited payoff. I mean, I commented many years ago that we crested the knee of the curve in terms of cost benefit for what you get. We're still climbing in terms of making more valuable things, but we are you don't get the extra bang for the buck of twice the power that you used to. I mean, it used to be when you're climbing the hill, doubling the power gets you a whole bunch more stuff. But we've crested that knee, and doubling the power that we push into something gets us slightly better looking things. And there are whole sets of techniques and people. It's like, find old timers that anybody that worked on an Xbox, an original Xbox or a GameCube or something like that, and tell them that, well, our minimum clock frequency is 800 megahertz or something. 800 megahertz? It's a lot of power that we've got on the phones, but people are so used to having multiple gigahertz and incredible GPUs. But it's absolutely possible to do great things with that. It's still a little bit different in that while we have lots more pixels that we need to draw. It's like 120 megapixels per second or something is what you need to do Gear VR quality, 60 frames per second stereo, which is a big difference from the 10 megapixels or so that you would have rendering to an NTSC TV in the old days. But you still think the same basic things. You don't use crazy techniques. You're not using subsurface scattering. You're not doing multiple layer order independent transparency, different things like that. But I know it's hard. Jason Rubin made a comment that the developers that have tried to work on Gear VR coming from the PC, it feels like they lost a level, where they feel bad because they feel like they're less than they were before. It's like the AAA developers became indie developers, the indies became hobbyists, and the hobbyists failed. And it's just harder. It's true. So I hope to inspire some people to buckle down, learn the right techniques, learn what you need to do differently to actually make that happen so that we can get richer sets of content on this. There are plenty of people out there that I think should be recruited into the VR space that have been there and done that on systems from 10, 15 years ago and have skills that are transferable to the optimization here. But largely it's a design challenge where you want your design to be in sync with what the hardware does rather than bullying your design through sort of against its will. And that's why I do think it's important to start knowing the capabilities of the system that you're going to be deploying on. Rift as a development tool for Gear VR makes a ton of sense. The development cycle on the Android phones is really not good. I spoke to several people that are setting up labs for students to learn VR development, and my advice there is you definitely want to be using high-end Rift PCs just so that it's not ridiculously hard to get that first satisfaction of making something work. But eventually you have to figure out like which changes you make in your limitations. Like as an artist, I like to think that a good artist can go ahead and make something great with just about any medium. You know, you see sometimes magical things that artists can do with just a few lines to convey a composition of something. But there's a lot of kind of pushback sometimes to giving up favored tools. And you have to make sense, like you don't want to make an etching with chalk. You just have to do the right thing with the tools that you've got. You can't change the tools right now of the hardware, so that means your design has to change. You know, you don't make it in a vacuum. So the Oculus Rex team in Seattle, composed of world-class content creators, they did some work on Gear VR recently for the Prologue project, and I heard there were some grumblings at some point about working on stupid puny cell phone, whatever, but they did some beautiful work with it. And I have that confidence that artists that are made aware of the limitations and can understand it, and it's an understandable process. And unfortunately, sometimes it's not, where what's making it slow. Is it my texture, my vertexes, my resolution that I've set it up at? So I would say that's the best plan going forward, is the more knowledge that we can make visible to people, the better. Now there are objective measurements of quality. Design is an abstract thing, and there's, we can argue about some design things about, it's like arguing about humor, whether something's funny or not. There are some things which are not objective, which are going to be subjective to the individual user. But there are some things about application quality that absolutely are objective. Load time is one of them, where I'm always happy to see in the mobile space where they have like app races about how fast each phone, phones can load and reload different applications. I think these are valuable things that the game industry, in contrast, generally has. Like on consoles, you'll have a TCR where you can't spend more than 30 seconds or so loading, and most teams are fighting and struggling until they can get down to 29 seconds and call it a day. And that's acceptable in a situation where you're going to sit down and you're going to play for an hour. Then if it took you a half minute for every level transition, that's probably not bad. Maybe you've even built that into the tempo of your pacing of your game. So you amp everything up and they're almost happy to have a little bit of loading time. But initial startup time really is poisonous. An analogy I like to say is, imagine if your phone took 30 seconds to unlock every time you wanted to use it. You would use things a lot less. And we're at that situation with Gear VR right now, where even aside from the pulling your phone out, maybe taking a case off, docking it in, getting it settled on your head, it can be 20 seconds till you can interact with home. This is not a great thing. And then launching out of that to the application you actually want is even worse. And then that can take potentially, there are apps that I wanted to play that I thought looked great that I stopped playing because they had too long of a load time. I would say 20 seconds should be an absolute limit on things. And even that, I'm pushing people for much, much lower. One of the things that I've been happy to be able to talk about with a term now, the show *Halt and Catch Fire* had a little bit in it about the Doherty threshold, which was they were trying to make it dramatic about getting below 400 milliseconds response time there. And there really was a paper published by an IBM research scientist talking about the importance in productivity of bringing actions down from a 2-second time down to 400 milliseconds or so. And it's great to be able to point people at that rather than just saying, efficiency, making it happen fast is really important. So I would like to see this in VR apps. There's some things that we've built, like there were some VR script applications and some of the new VR shell stuff I hope to get to talk to at the end, where you could be jumping between things super, super fast. And it's an unexpectedly pleasant experience to be able to be jumping into things in a half a second or so, to have something just jump in, and it's your wish is my command. That's what we want out of our computing devices. We want them to be the genies that are instantly satisfying our wants and desires, not that we have to step-by-step command them through different things. That wraps up a whole bunch of different user interface aspects, but the ideal is once you've decided what you want to do, you want it to happen fast. You do not want to wait around. And in some ways it's worse in VR, because what people do for long loading times in the real world for things, you might pull out your phone, switch over to Facebook or something while you're waiting for your game to load to the next level. In VR, you're stuck there looking at, worst case, a black screen. In the simple case, everybody should be trying to just put up an asynchronous time warp, single panel, fade to black at the edge, draw it once, don't be running a scene, don't be trying to do anything clever. I see efforts for people to do animated load screens, doing shines around things, actually changing the scene. There's a number of reasons not to do that. One is that on a technical level, because of the way it works, if you happen to be looking aside and it's choppy frame rate not updating very often, you can catch it with your scene at the edge of the screen. Then when you look back over there, ATW may be pulling it in over here, but you've got everything sheared off at a black line because you spent a half second without updating the scene. But more importantly than that, just with almost anything that we choose to optimize with a number, it is so much better to actually make the number smaller rather than to hide the effect of this. And I point to a lot of the research work that went into like predicting head positions for virtual reality, where kind of pre-Rift era, there's lots of papers going about what sophisticated model of how the human head and neck moves do we use to try to predict 50 or 100 milliseconds into the future. And that's just wrong-headed work. What you want to do is get the actual latency down to a much lower value. So similarly with load times, the real priority should be don't take so long to load. Don't do multiple kind of clever things to cover it up. There's a whole set of techniques which are common knowledge in some circles about the way that you manage expectations. Disney is a master of this at the at the theme parks, where they have all the cues going through here. They go through different areas. They change what you're looking at. They try to not make it. If you were just in the back and forth metal turnstiles the entire time, it would be a much worse experience. But it would be so much better if you were just fast passing to the front on every single time that you went there. So applications should be like that as well. Microsoft did that in like Windows boot up times when computers were slower. You'd start on the BIOS screen, then it would go to one Windows logo, then to something else animating, and then finally it would get to like a login screen while it's still churning around in the background. But again, it's better to just like not require the resources that make it load so slow. So in terms of what's possible here, it's always useful to figure out what the speed of light is and then figure out how far away you are from it. So I did some timings on some of the phones and how fast can you load things. And I was measuring 300 megabytes per second reads from Flash. Texture uploads, depending on the system, 150 to 200 megabytes per second. So most of the time when I see an application that's taking 10, 20 seconds, 30 seconds to start up, I can load up like Snapdragon Profiler or something and see all the textures that are in there. And it's not like they're loading up 2 gigabytes of textures. There's other reasons why things get slow. One of the biggest a discussion that we're having back and forth with some of the Unity folks is that I would argue that the simplest, straightforward way that's least likely to get messed up with this is you just memory map files that aren't compressed and you text sub-image directly from there. But a lot of game engines are set up with multi-thread pipeline decompression schemes, which in theory, as long as you've got the clock rate up, you can be like LZW decompressing something at a faster rate in theory than you can read it from Flash. I agree on some systems. I'd be a little dubious at exceeding that on the 300 megabyte per second read range, and I'm agitating a little bit for you should have some option to be able to have your textures set up in this memory mappable format where it just goes in, starts up, memory map everything, upload, deallocate it. So there's definitely some possibilities there. Everybody should be using for almost everything compressed textures. In a native format, we use the KTX format, but just ensuring that their ASTC compressed is really important. I still come across big textures that are 32-bit RGBA that is costing you load time, power draw, thermal issues, and frame rate. It's across the whole board where the great thing about ASTC, its adaptive scalable texture compression, is unlike a lot of artists may have had bad experiences with DXT texture compression, where it was this fixed thing, it goes down to 4 bits per pixel, and sometimes it makes your beautiful art look like crap. It comes in and you could see these big blocky forms, or you've got colors lost because it only had 2 endpoints. ASTC is much, much better at at everything. If you pick the same 4 bits, it's still a whole lot better. But the neat thing is it's scalable. They have everything from 8 bits per pixel down to like 1.5 bits per pixel or something, and you can switch between it. Another thing that I was really happy to see, the Oculus Rex team on Prologue, I'm looking through it with Snapdragon Profiler, seeing what what all the textures are there. And it was the first time I had ever seen somebody actually using variable ASTC things. They would go and say, this one's at 8 bits per pixel, this one's at 4, this one's at 2. And it worked out really well because walking through the beta process on that application, we saw this great looking stuff, but we could point out, okay, I can see like a gradient here or a blocking artifact here. And at some point they went, it's like, well, that's going to get a little bit more bits and it's going to get fixed up. Most people won't be going through that one at a time texture kind of analysis question there. But if nothing else, never send something up that's static as RGBA32. Go to at least the 8-bit KTX. Every Gear VR, back to the original Note 4, supports those formats, and you absolutely should be using them. The next thing that can kill you is shader compilation. Like we had a killer case in Time Warp, where when we went to our flexible layer system, we had many more possibilities that could be combined into the shaders that you could use there, because at one point we started compiling all of them, and we had this point where it was taking 5 seconds to start up our simple native apps just to get going. What the heck is happening? And it was because we built a couple hundred shaders at that point. We went to dynamically doing it, and this is something that old timers will have a bit of a knee-jerk reaction about dynamically moving, doing a shader compilation. That's going to add a hitch in your frame rate sometime. There are reasons to avoid that for general purpose things, but because a lot of these things happen at understandable positions, sometimes at scene transitions when you go to something different, it really is good to defer creation of some of those things there. Like if you've got something that's multiplayer or social based, and you know that a bunch of people are going to be starting up in single player, don't create those resources at the beginning. Wait till it's actually needed. So Android does cache binaries for you automatically, so there's no real benefit to using like the binary shader extensions, shader caching extensions. And then one of the really big things that came out is because we limit the clock rates, we let you pick which CPU level you're at. Generally, for better battery life and thermals, people choose as low of a CPU level as possible. That's the right thing to do during your applications. But it does mean that any loading that's going on is happening at that very low clock rate, which you might be at a third or less of the peak clock rate, and that could make your load times 3 times as long in some cases if you're totally bound by CPU rather than I/O. In all of our native code, we've got it set up now so that you start up and the clocks are unlocked. It's just like a normal Android system until you render your first frame. Unity, I think, is set up like this now through the initial load, but I don't believe we've got that yet for in-game transitions, like when you load new data sets. So that's one of the really big wins that we should be able to get out and make more general. But that's yet another reason why you should not do fancy loading scenes, like going to a scene that's doing things. We want to use the built-in transitions as much as possible so we can automatically fix some of those things up for you. Yeah, switching. Another thing that I'm hoping to get as we move towards some new application paradigms and standalone and things like that is right now we are one VR application at a time. We let home kind of live on, but we want applications to eventually get wise enough to be able to act like normal Android applications, of letting them go into a pause state, letting them come back. So we will get to a world where people are switching between VR apps just like they switch between apps normally. It's not clear if it's exactly time for doing that yet, but it's getting close. As an example of how things go badly, Cinema started off as a very fast-loading application in the very early days, but we added more and more things to it, especially these large theaters. The theaters are 40 or 50 megabytes each. And at the start, we were just loading all the theaters all the time, and it got slower and slower. We had our native app that was taking a really long time to load. So it was clear it needed to move to defer those loads. Most people are not going to be switching through multiple theaters each time they go into the theater application. You should obviously just wait till they even get in there. They might not need a theater at all, because you could go into the lobby and then pick a 360 video and then quit back out without ever going into the theater. Or even more so, you could be launched from another application with an intent and load a 360 video and never even see the lobby video. So deferred loading is a really important thing there. There's the puzzle solving part of my brain starts thinking about what is the speed of light case for a lot of these things, where it turns out it winds up being sort of a dependency graph of sometimes you have to establish a network connection, figure out you need to do something, then maybe you could spread out a lot of threads to do multiple resource loading or shader creation at different times, wait till you get a DNS resolve coming back and do different things. And it's in the limit, it's an interesting problem, but just following sort of the 3 key things will get you a long ways. Now, Android does some exciting things to make applications load fast, where I had a point a few months ago where I was launching standalone Android applications where not part of the normal Android ecosystem, just run as an EEX from ADB. And I noticed that OpenGL was taking like almost a second just to initialize EGL. I'm like, that's, normal applications start up much, much faster than that. I asked someone at Google, is there any Zygote magic going on with this? And he was, yes, indeed. There's the thing that Android does that's pretty clever is all of the systems kind of spawn off from a Zygote process that pre-links all of the libraries that they might need and does a bunch of setup, including some of this OpenGL stuff. So Android's paid a lot of attention to things like smooth frame playback, application startup, and these are things that anything that's important to 2D is probably going to be important in 3D as well. So frame rate performance is what most people think about in terms of optimization. And the Unity people tend to over-index a little bit on draw calls because when all you've got's a hammer or all you're aware of, then everything looks like a nail. And draw calls are the thing that everybody calls out as like, this is what's going to kill your performance. But often it's not. There's a lot of other things that can be killing you. Too many draw calls definitely will kill you, but we've seen too many cases of people that have completely reasonable draw calls and still have poor performance. Now, multi-view is going to be the thing that helps the most for draw calls, where it essentially cuts in half the cost of the draw calls. And this is one of the failures of the Android ecosystem where we're at right now, where it's been over 2 years since we started talking about multi-view and we started getting extensions for this, and we still cannot deploy it universally across our applications. It does work on the Exynos chipset ones right now, but it still is not enabled on the Qualcomm chipsets because there's a bug that basically doesn't let it work the way it needs to for this. And Qualcomm's fixed it a long time ago, but it needs to get into Samsung. Samsung needs to get into an MR. It needs to get out. Carriers need to pick it up. And this is terrible. I think the S7 still hasn't gotten most of the things that we know are fixed that are causing performance problems there to get rolled out. This is a pretty fundamental problem. And it's related to the way things were on the PC 18 years ago or so, when you had all of these companies getting chipsets, and many of them, they would tweak the drivers to cheat on a benchmark in various ways, and they would have their own version of it, and it was terrible. You had, even if they were just NVIDIA and AMD parts, they had custom drivers on different systems, and they didn't get updated, and it was so problematic. The world is clearly a better place with NVIDIA and AMD doing direct-to-consumer driver updates. For all the problems that there are with over-aggressive optimizations and various things, it does mean that you have a hope of discovering a bug and actually getting it fixed. We are in cases where bug is discovered and years can go by before it actually gets rolled out. Because most of the time you need to do this iteration. You say, okay, here's a new extension. You need to actually try to use it. Ideally, you need to try to use it 3 times in 3 applications to have any confidence that it's actually working. And when you find bugs, as happens most of the time, it needs to go back to the hardware vendor and they need to get a fix. But it's almost here. So multi-view is going to help a lot. It's going to basically halve the cost of the draw calls, which will save a lot of CPU. I hope that everybody doesn't go out and just throw in twice as many objects for things, because we want this to actually be a savings on our thermals and, and frame rate drops and all the various things there. But the big win's going to be when Unity and Unreal have support for it. They're working on it. I don't have an ETA for it. I'm hoping that it's going to be not too far away, because a lot of apps will benefit a lot from this. We see in our native apps like Cinema it's basically nothing but a lot of GL draw calls. So we saw in one case literally a 50% decrease in CPU, because there's not much going on. The video's playing, your head's moving around, there's hardly any computation. All we're doing is 80 draw calls or something. So putting in multi-view, it cut that in half. Now that only turned into maybe a 10% or so power advantage in terms of how long you can play or the thermals, but it still helps. The biggest thing that you can do for getting good performance, and it also improves the quality on Gear VR, is building your application around pre-lighting, where instead of, definitely avoid things like specular bump maps, a lot of dynamic lights, things like that. These are things that it's a triumph that in the high-end world we can do this, and you can build games that are built around this and require it, but it is so the wrong thing to do on Gear VR. If you're willing to pre-light things, the thing that we have in abundance is texture memory. You can use a gig of texture memory. I mean, I don't recommend going that high just because load times and download times and all that. But these phones, you can have a gig of compressed texture memory, which is an enormous amount of textures that are shown at very high quality. So you have the opportunity in most VR applications. Most of them are not free roaming. Most of them are limited to a few specific areas. I still want more free roaming games. I think there's a lot of magic to be had there. But when you've got a few specific points, you can pre-render that scene at extremely high quality. Again, Otoy has some examples of baking high-quality lighting onto relatively low-fidelity meshes. Every artist has their own sort of pipeline for doing this. Like if you look at our cinema scenes, were all done like this, where you build something high-quality, use whatever tool the artist is comfortable with to lay out the textures and generate the lighting there. This has multiple benefits where it looks great with the high quality lighting. It also importantly filters extremely well. Anything that you're doing a calculation on the pixel that's not completely linear, you get those subtle things as you move your head around, things sparkle and weave around a little bit because the changes are not exactly summed up by the bilinear filtering. If you pre-light everything, it's going to look great all the time. That's one of the most important things you can do. It takes an artist that knows the tool chain, the way to do that. It does make re-rendering and changing sometimes less flexible. You do your layouts and experimental testing before you spend all the time to do it, because sometimes these bakes may take days to do, depending on the hardware you throw it to, but they really do look great. And again, compressed textures wind up being an important thing. One of the things that's been a little bit surprising to some people is in many cases, when you're using compressed textures, you wind up not spending much time in the fragment shaders. It is not uncommon to see vertex shading becoming a bottleneck on these systems, and sometimes for reasons that seem a little unexpected, because vertexes may need to be shaded more than once because of the binning or tiling nature. So sometimes you see vertexes, I'm looking at some pixels, and the cost in vertexes is more bandwidth than the cost in shading the fragments. One of the things that it looks like almost nobody's doing right now, it doesn't seem to be the standard Unity options, but compressing the data that's going to the vertexes. Instead of just saying everything's a float, texture coordinates are float, vertexes are float, normals are floats. Most people that work on consoles are very familiar with, all right, we're going to put these down to unsigned bytes. This will be a half float. We'll add a scale in the vertex shader as necessary for this. And there's some good performance to be had there. Vulkan will be an even bigger performance improvement than Multiview. It's one of those things that we were, again, fairly pleasantly surprised to see. Multiview, in straightforward cases, doubled our performance. In some cases, Vulkan could double it again. Vulkan is definitely a mess to work with. We don't have all the things worked out to be able to use it in VR yet, but that's coming fairly soon. But again, it'll be gated on Unity and Unreal, delivering that for people to get real value from it. But hopefully that will be something that's coming around later next year. Anyone doing native code, we did recently deprecate the KitKat Note 4 support, so that does mean you can rely on OpenGLES 3.1. You can't rely on 3.2 yet for everything, although probably more so than most markets. If you want to shoot for just the latest and greatest headset and the latest OS version, you might not be hurting yourself as much as you would think based on maybe other Android stats or some other thinking. The Oculus performance tool, I want that to be the first tool that everybody reaches for to grab and take a look at why your performance is not great. It's a little shaky right now, but it's working its way up. I'm hoping that we can dedicate a full-time engineer at some point to just saying this is going to be the tool that we just want everybody using all the time, whereas right now I only grab it when I'm not getting the results I need from a cursory evaluation some other way. I don't reach for it as fast as I wish I did, so I want that to become a better tool. The tool that I've had the kind of love-hate relationship with is Snapdragon Profiler, where when it's working and it's getting better and better, it is really valuable. It can capture, you could do a couple important things with it. You can capture a snapshot of your frame and then go through every draw call, see what the bandwidth was used for all of it, evaluate how much textures you're using, what the shaders are, and it's really useful. And then you can do a real-time trace of how things are going dynamically, or you can do a trace capture, which is like a systrace in that it can capture all the CPU stuff, but critically for graphics programmers, you can also capture the exact things that are happening with the GPU. So you can see the difference between when it's rendering eye buffers, when it's resolving things, when it's doing the time warp. And I need to make another blog post that has some pictures about this where you can see whether it's a healthy designed application and you see just eye, time warp, versus an application which is tripping over itself and might have unresolve of a color buffer, render to a separate frame buffer, back and forth here, and having some of these things that are really unnecessary or should be designed around. And it was to the point where it worked on some old Note 4s, and I never got it working right on the S6s. It's right now I have it working on a Note 7 in my office, and while we're supposed to swap out Note 7s, it's like someone's going to have to come in and steal that from me because I don't want it to go away right now. In visual quality, the last blog post that I did write just in Facebook, where apparently somebody is trying to get images for it to put it up and put it officially on the Oculus blog, but I went over all the things about visual quality and aliasing. And this is something that I speak about in practically every single application that I look at. The quality is not what it should be. And again, the reference quality that everybody should look at is the super high quality 360 photos, where ideally all graphics would look that good. It would have that sense of solidity, that it is stuck there, you're looking around, and it's not rendering it for you where you see pixels coming and going. And I laid out like the top 4 or 5 things on there that are really important. But anti-aliasing, using a forward render with multi-sample anti-aliasing should be basically a requirement to get in the store. Again, I would have waived that for Minecraft if I could have gotten it out earlier, but every application that I look at other than that that doesn't have it on, I would say you need to turn that on before the store will accept it. We have made our defaults right now have been set up so that we default to 4x MSAA for the Mali and 2x for the Adreno, because it's almost free on Mali and there's a modest performance cost on Adreno. I would actually recommend changing that now. I would recommend always going at 4x, and if you find out that you actually are fragment bound on Adreno, just scale down the view buffer a little bit. Use a 960 instead of 1024 or something, because that's some of the best quality that you'll get for a modest change. And that doesn't take re-architecting anything. It's just, I want this MSAA, and maybe I need to switch down the resolution of the buffer a little bit. The thing that jumped out to me on several apps that I reviewed on Wednesday, there's got to be some Unity sample that people are copying and pasting that's doing the kind of wrong thing here, where there's a clear case of people download images from the net, and they come in probably as a JPEG, and it's not generating mipmaps. So I see this case of, I'm looking at the Fox Sports application where they had a really good looking scene around it, a lot of things that I thought were very nicely done, but then they had the panels to select it, which were dynamically streamed down, and they were aliasing just horribly, where it looked like they had probably pulled down an image that was at least twice the resolution that was necessary, and it was being crunched down, drawn like that, which is bad for performance. But the worst part is everything is fizzling. Everything is moving where the constant microscopic motions of your head are causing the pixels to come and go and jump around. So this should again be, we need an automated test for this somehow that's capturing things. If you draw an image that's not mip-mapped, unless you totally know what you're doing with pre-filtering and sizing of things, you should always have mip-maps, and you should always be in trilinear filtering. That's one of the biggest things that jump out. Some of the subtle things that I point out to people beyond the most blatant obvious things that are hardware restrictions with Gear VR. Most of you have probably seen these. It's worth designing around them. If you have something that goes all the way to a deep black, then you have deep blacks and then like slight gradients up. As you move around, there's this nasty smear effect that happens just based on the way the displays are responding. On PC, they do some neat stuff with overdriving the display and time warp to try to compensate for that. We really can't afford that on Gear VR. It's a lot of extra cost. So avoiding solid black next to other dim colors is useful, but then you also want to avoid full white, especially if it winds up being kind of in the extreme corners of your vision, because the 60 frames per second display on gear causes more flicker sensitivity, and the bright colors are a bigger issue for that. In UI design, okay, I am running out of time, so I got to get super fast on some of this stuff. So the biggest thing that I want to impress on people is that you should not design VR apps just to be novel. And this is a mistake that practically everyone makes to some degree, of saying, this is virtual reality. I don't want a boring old style interface. I want something that, that uses VR. I want things over here and moving around. And this is just misguided. This is not a matter of saying, well, it hurts your performance or the visual quality isn't as good. It's actually not the right thing to do. In terms of the user interfaces, if you've only got a couple options, then no big deal. Do your big giant floating button. But as soon as you've got enough complexity and that performing the operation is actually a task, like find what you want to look as you browse through a lot of these things, or read this paragraph of information, or read this post that's going on, these are things that actually are best done on 2D surfaces. And more than just 2D surfaces, they're best done on opaque 2D surfaces, where there's a design aesthetic to use lots of transparency and to think that, oh, it's neat that I see through this. And this is one of the things that the movies perpetuate badly, where everybody's vision of the future has the translucent things popping up that you're poking at in space. And you really do not want to have things on translucent surfaces. You do not want to have text floating over empty space. Every once in a while, you'll come across a store in the mall that has text on a window, on a store window. And it's worth looking at how unpleasant that actually is to read relative to something that's printed on an opaque poster board. So you really do not want to do floating text, because it's worse in VR, where in traditional gaming, it's surprising how much you still see this. Traditional game developers are at least aware of it, and you'll think, okay, we'll either do an outline or we'll do a little black smudge behind it, but you still see some problems with it. But not only is it as bad as traditional game design, it's worse because of the actual different depths of vergence that you've got, where your eyes are reading text, but if they can twitch to something that's in the background, your eyes actually are moving back and forth, fighting the lack of focus, the lack of varifocal in VR, and it's really a bad thing. And designers are usually not, working in Photoshop or something. It's like, oh, this looks good. I've got my nice high-res layout, with the fonts setting on there. It looks okay. But in VR, and maybe they glance at it in VR and say, yes, that's my vision. But if you live with that design and you work with it for hours at a time, you're using it every day, you don't want to inflict that on your users. You want opaque backgrounds, legible text. And the biggest thing that I want to push going forward is, I call it the surprising optimality of 2D interfaces for VR. I actually think this is the right direction to go, that we want to be pushing. Design it like a great 2D UI. Designers have so much experience here on making the mobile apps, web apps. We know how to do this. We have tools to let us do this well. Build an awesome UI there, and then use time warp layers to project it onto the screen at this super high quality pixel fidelity, so it looks with the solidity of the backgrounds, the 360 photos. Every pixel counts. You get it at the right scale. It's not this abstract scale of abstract GL coordinates or something. You can say this is going to be 600 pixels by 400 pixels. Time Warp will set it up and position it so that it's exactly right. Every pixel that you make in there makes a difference in VR. It comes out perfectly filtered. You can use the magnifier on your desktop to zoom in and change the pixels, and it makes a difference in VR. We can get quality that is several times more what we've got right now. In the actual games, when you have to present something and you can't use a layer for different reasons, you want to make it big and bold. I try to say, what would Nintendo do? If you look at what a game like a Mario or a Zelda game, and there's a lot of subtle wisdom in things that maybe they've only got 3 things and 20 characters that are put up there that are communicating the important things, but they're big enough to be legible, and that's the way you need to design in VR. I saw dozens of applications in the last couple days that had text that was difficult to read, that was fizzling in and out, and text can add a lot of value. I commented how much more valuable 360 photos was for me when, instead of just swiping through random great-looking photos, they had the little sentence or two that came with someone's Facebook post saying what it is, that grounding that it adds to it. That was real value, but text has to be comfortable to read. Many times in the last couple days, I was presented with text that was literally uncomfortable to read. I had to concentrate and focus instead of just the instant snap, being able to grab something or sight reading through it. You had to stop and read through it because the letters were moving around. It was hard to see. There's immense value to be had there. There's things that with scrolling, when you're presenting a large list of things, I think it's been a tragic UI failure in some of our Oculus's early stuff where we've designed for this safe zone, like it's a TV set, where you can't go near the edges because you might be covered by a bezel. So we have this small set of tiles to select from, and maybe you can swipe and scroll through it. And I think that's bad for several reasons, where ideally you don't want iconic representations of things. When you're browsing for new content, you want something that sells you on the content. And one of the things that's been interesting is I think there's a minimum size, sort of a minimum field of view for presenting an object that makes it feel beautiful and enticing. When you shrink things down far enough, you're making an icon that you will sight recognize, and you can choose and jump between icons directly. But if you want to show somebody something, do you want to look at this? Is this enticing? Do you want to buy this application? Do you want to look at this photo or view this movie? There's a minimum size and a minimum quality where you start appreciating the movie artwork or the thumbnail for what it is, rather than sort of a key to what it will become. So I think larger things and letting it go all the way off the screen, letting it kind of cover the entire edges there so you can have bigger things. And when you see something at the edge of the screen and it's cut off, you know that informs you that you can scroll, that there's more there. We've had failures in some of our design where we have a list of options and there's more options there and you can scroll. I did this with 360 photos where I needed to go, where did my photos go? We had added one more option for the Olympics or something, and it was added off the scroll list. Now, we had the little drippy scroll bar thing on the side, but I didn't actually notice and appreciate that that was there because I saw 6 options or whatever there, and I thought, well, where did it go? Is there some other way to get to it? If you've got a scrolling list, ideally, if it goes off the screen and you see part of it, humans instinctively know if something is kind of cut off in your field of view there, all you have to do is look down to see the rest of it. And that's a very valuable thing to be doing in VR. If you have to cut something off inside the visible space, literally cut it off. Make sure that you don't show an integral number of things. Show half of something there, which gives you a little bit of information, and have a demarcation line. Don't just stop in space and expect things to magically fill in. Have something that cuts it off and restricts the view from it. A ton of UI things, like all the things with the gaze cursor, where these are lessons that we're learning over as we're building these things. The early native apps had gaze cursors that would move around, and I did this funny fizzly thing when it was projected behind things because it's really bad to have something that's at the wrong depth. That's one of the worst things you can do to users in VR, is have something like your gaze cursor that goes behind a physical object, but it's actually drawn on top of it. That causes your brain to fight with your eyes about what it's seeing. And there can be even worse things with macroscopic geometry, but that happens unfortunately commonly with the gaze cursor. So I've really moved my opinion from, at the start we were thinking we were going to have these crazy VR 3D UIs, interesting things going on, and maybe you're going to be interacting with lots of different things. Now I'm all about this optimal 2D user interfaces, because another side benefit, aside from the goodness of the layer projection, the goodness of all of the tools, it means you know exactly where your cursor is supposed to be. The cursor should be presented as close to possible of exactly on the surface. You don't want it floating ahead of it, because then your eye does this weird little clicking between focusing on this at this distance and then focusing on what's behind it. You want it to be on the surface. And you actually want it to be gone as much as possible. There are so many cases where a gaze cursor is left up and it's doing nothing useful. Like you've got a lovely environment behind you and you're looking around, but you've got the little cursor floating around, really just kind of getting in your way. You have cases where you bring up something to read and the cursor's right in the way as you're trying to read things going across it. The cursor, if it's drawn into the 3D world, is also a frame rate indicator, where that's one of the first things that when I look at a game, I move my head back and forth. If you see a double vision of the cursor, it means it's running at 30 frames per second instead of 60. We can fix that with time warp cursors, where you can put that on top of the layers, and then it will never skip frames there. It'll stay smoothly around. but you want it to go away as soon as you can. Interestingly, you don't want it to snap away just as soon as it's off of a visible or an interactable object, because we had a case with the Oculus Prologue where they had a relatively small thing to click to go to the next area. And they had the gaze cursor go away when it went off of it. And it was surprising how many people would have trouble finding where they were, where you don't have a good sense of exactly where you're looking at without a cursor. If something is less than maybe 20 or 30 degrees of visual arc, it's hard to point on that without the cursor. So you need to make it become visible when it's within, say, 15 degrees of an interactable object. And the best thing that I saw, again, Prologue did a great job of, instead of just fading or blinking the cursor out, they had it shrink away into the distance, which worked out nicely. I thought as you came in, the cursor grew up into being, and then you could place it over an interactable object, and you could do something useful with it. Say 2 minutes and go. So some of the things like one thing that I saw one of the applications do is we are getting a user interface paradigm that people are expecting. They had double tapping to make something make it perform its action, which is something that just feels weirdly wrong, because we have several hundred applications now that have certain paradigms for working on things. But they were trying to address a real problem that we struggle with, is that when you give it to somebody that doesn't use Gear VR all the time, they're always mashing their hand onto the touchpad, they're settling it on, and it's activating things. But one of the alternate ways that you could solve that is to have a smaller activate button that you have to at least be able to go and tap just to enable the user interface, and then make it real after you've mounted. Similarly, something that I've come around a little bit on is the use of gaze and wait timings, where I railed against that in the past, like kind of the Kinect, the 0-button mouse sort of effect of you hold it there and you wait. In all cases, you should be able to tap to complete those, but I kind of buy into many passive experience cases of people not even wanting to lift up to the touchpad there. You want to be able to just look around, look at something and wait a little while, wait a couple seconds if you're not in a hurry. But in many cases, when you're active, you want to be able to make sure you go tap, tap, tap. You want to be able to accomplish things in hundreds of milliseconds. So you always want to be able to click that clear. The gaze cursor, distracting from the scene, losing the ability of indicating something to interact with. One case where it turns out you can remove the gaze cursor is if you've got a large field of panels of apps, and one's always selected and you don't have spaces between it, you don't need a cursor because one is always going to be selected. You can always be looking around, you see which one is selected. There's subtleties there about you want a hysteresis between the selection, where you never want to be able to sit on the knife edge of something as it jitters between two selections. You want to give your current selection a broader area until you finally fall out of it. Then it can revert back to selecting the other one. All right, they say I'm totally out of time now, and I'm 3, 4. I had a ton more things to go over. But again, anyone that's interested, we can probably adjourn to the hotel lobby or something, or wherever they chase us out. So thank you all. Excellent.